Okay. So those students who are having the doubt, they only unmute and ask. So I'll repeat the number of times, the derivation and the problems. Slowly we'll do. So on the screen, what you are able to see, anyone read out? Derivation of temperature coefficient.
Derivation of temperature coefficient of resistance.
So for the mid examination also, this derivation is important for external also. So first we'll see what is a definition. What is this temperature coefficient of resistance means? Whenever any object is heated or whenever current flows through the object, whenever any object is heated, there will be the change in the resistance of that object. So whenever current flows through this copper conductor, the conductor gets heated up. As a result, there will be the change in the value of the resistance. So with our eyes, we cannot see what is the change in the resistance. But if I'm placing the sensor, I can calculate what is the change in the value of the resistance. So temperature coefficient of resistance means change in the value of the resistance to the change in temperature, or whenever temperature changes, the resistance of any object changes. So how to what value the resistance is changed is explained by the temperature coefficient. So what we have written, temperature coefficient of resistance is the measure of change in electrical resistance of any substance per degree of temperature change. That is, whenever temperature changes, resistance changes. What is that value of the resistance which is changing? So to what extent the resistance value changes? So in simple language also we can write. So we have to show with the formula. So what is temperature coefficient of resistance means? Whenever temperature increases or decreases, resistance of any object also increases or decreases. So we should explain with mathematical relation. Okay, so now we are taking the derivation. So let us consider a conductor. Okay, conductor here I am showing, no need to draw in examination. Let us consider a conductor or copper wire whose resistance is R at 0 degrees centigrade. That means no heat energy is applied. And resistance B, let the resistance be RT, R suffix T or R into T at T degrees centigrade. That means after certain period of time, when the conductor or any object is heated up, so let the resistance be RT at new temperature. What is the new temperature? T degrees centigrade. Okay. And what is the initial temperature? 0 degrees centigrade. So let us assume a conductor resistance is R at 0 degrees centigrade and conductor resistance, new temperature resistance is RT at new temperature, T degrees centigrade. So what is the difference? So the increase in the resistance, that is delta R, the change in the value of the resistance is equal to the new resistance minus initial resistance. So what is here they have written R, you can also take it as the R0. So here we will modify this one as R0 or R0. Let R0 be the resistance at which temperature? 0 degrees centigrade, and RT be the temperature at T degrees centigrade. So what is the change in the resistance? Change in the resistance is taken as delta R, which is equal to new resistance minus initial resistance, that is RT minus R0. I hope this is clear up to this point. Okay. So how to start the derivation? Let us consider a conductor. Initial value of the conductor at 0 temperature is R0, and at new temperature after certain period of time the resistance is RT. So change in the value of resistance delta R is equal to RT minus R0. Okay. Okay. Now, so RT minus R0 is directly proportional to resistance into temperature. That is why we are writing this expression. Increase in resistance. So what we are saying, when a conductor is heated up, there will be the change in the value of resistance proportional to the change in temperature. That is, whenever temperature increases, resistance also increases. Therefore, we say here the change in the resistance is directly proportional to initial resistance R0 into temperature. That is, increase in resistance depends on its initial resistance and rise in temperature. So we say, let us take the example. First, the resistance value is 5, and after certain period of time the resistance value has become 10. So the 10 depends upon the initial value. What is the initial value? 5. Okay. Therefore, the change in the value of resistance is directly proportional to initial resistance into temperature. Here we have written. Okay. Now, so what is this one? RT minus R naught is nothing but delta R. Change in the value of resistance is equal to certain, it is directly proportional we have taken. Now we can take directly, assuming it is a constant. Now I am saying this is the constant of proportionality alpha, certain constant value. We can take the beta also, alpha into R naught into T. Okay, we already know directly proportional after equal to we can take certain value. So change in the value of resistance is equal to certain constant into R naught into T. Okay, initial temperature. So now from this expression you bring R naught to the right hand side and take R naught. What is the expression we are getting? Resistance at any temperature. Resistance at any temperature RT is equal to initial resistance R naught into 1 plus alpha into T. This formula you have to remember. Temperature coefficient of resistance, or what is the relation between resistance and temperature. So you must remember this formula. RT is equal to, RT means what? Resistance at a new temperature is equal to R0 or R0, resistance at initial temperature or 0 degrees centigrade into 1 plus alpha into T. T means temperature here. Okay. So once again I repeat, explain how it is possible. Let us consider a conductor which is having the 0 degrees centigrade temperature, and let R naught be the resistance. Okay. Let us consider the same conductor after certain period of time with new resistance which is increased and at new temperature. What is the new temperature? T. Yes, anyone? Any doubt is there? You can ask. Okay, the new temperature is T. So what is the change in the resistance? Change in the resistance is taken as delta R is equal to new resistance minus initial resistance, RT minus R naught. So RT minus R naught is directly proportional to initial resistance into temperature, because the change in the resistance depends on temperature, which is equal to constant alpha we have taken, and just bring this R naught to the right hand side and R naught is taken common. So RT is equal to R naught into 1 plus alpha T. This derivation is important, 3 lines derivation. Okay. So if you are not understanding, you can ask once again, but first let us move to the next topic. Generally also we can ask, you can ask any question for this one. So what is this? It is heated up or cooled. So any object, if it is cooled, its temperature decreases. When any object, when it is heated up, its temperature increases. So what is the relation from its initial value and final value? That is, when temperature is increased, what is the value of the resistance? In that manner, this derivation is useful. Okay. So let us take welding. You might have seen in the welding process, you will come across this change in the resistance. Now we are taking, yesterday we have taken the theory part. So first I will take the next type of problem now. Very important problems here. All of you, this topic is related to unit 1, but in the examination you will get all the students. All of you are able to see the graph on the screen. Please confirm, anyone?
Yes, sir.
Yes, sir.
We can, sir.
Yes. So unit 1
Yes,
I
sir.
kept. Today I will be releasing the unit 2 material. You can study that material. That's enough for exam. So AC current, the current which flows in 2 different directions is called alternating current or AC current or bidirectional current. We have studied. Mathematically, we also call it as the sine wave, because it is not constant. It is continuously flowing through the wire. Therefore, it is sine wave. Okay. You can call it as cosecant, cot, tan also. But any other trigonometric function can be converted into sine. That's why all engineers given the name as the sine wave. AC current or AC voltage or sine wave. So all students might have remembered. So what is the peak value? Anyone tell me definition? See, the maximum position reached by the current during positive off cycle or negative off cycle is called the peak current. Okay, you have to read the definition. This is the peak voltage or peak current. Okay, next we have taken RMS, mean means average. Now first, today's class, what we are studying, what problem. So if you are drawing every time, no need to draw these values. Okay, so AC current or AC voltage starts from origin and it has got positive off cycle and negative off cycle, and this voltage is not constant, it changes with time, it depends on time. Or theta we have taken, that is, it is rotating in circular direction, circular or graphical direction, it is not moving in a straight line. Okay, so any object which is moving in circular direction or which is moving in curvature at certain different points, it is also changing with respect to theta. Okay, trigonometric function. So now we write the formula. Today onwards, remember what is the AC voltage. What is the voltage formula? Anyone tell me from Ohm's law? Voltage formula, V is equal to I into R. Okay, V is equal to I into R.
I into R.
But that is possible only if you are using battery. But here I have mentioned Faraday's law, we are having North Pole and South Pole. So AC voltage means you must remember what is the formula written here? Small e. E is equal to Em into sine theta. Okay. Here the Em is nothing but another name is Vp also we can say. Em into sine theta. Sir, why you are writing Em? Em is nothing but the maximum position in positive of cycle and negative of cycle. Here in the graph it is shown Vm. You can write Vm or Em. So instantaneous means value of the voltage at any time, at any period of time. So I want the voltage at this point. I want the value of voltage at this point. It is given by instantaneous voltage. Value of the voltage at any period of time is called instantaneous voltage, which is given by E is equal to Em. Why you are writing here means this voltage contains positive peak, the maximum value. Okay, I have written. And this waveform is also called as sine. Okay, I have written. And this waveform or this current, it is moving in linear direction in straight manner? No, it flows in circular direction. It is having positive of cycle and negative of cycle. So it depending on the angular axis theta. So we can write the theta. Okay. Yeah. So this problematic part, this introduction is very useful. So I make it clear here. Today onwards, AC voltage. Which voltage which is coming to our house? AC voltage. What is the formula for AC
voltage?
Yes. What is the formula for AC voltage? E is equal to Em sine theta. E is equal to Em sine theta.
Theta.
Yes. So what is this theta here? Any object which is rotating in circular direction, that object is represented as in terms of the theta. Your fan also rotating in circular direction. Fan equation also we must write how much voltage fan is taking. So the voltage formula is E is equal to Em sine theta. So now we say theta, another name, theta formula is, you can see F into 2 into pi into T. Theta is equal to, you can write here as F into 2 into pi, 180 degree. See here from 0 to this is how much here, 0 to 180 degrees. I will tell you here 0 it will start, this will be 90 degrees, here it will be 180 degrees, and here it will be 360. So what is the basic of cycle here? 180. So therefore here pi means 180 degrees. So what is the formula for theta? Theta is equal to F into 2 pi into T. That's why this formula is written. You can write theta or you can write the in terms of the frequency. Frequency is equal to number of cycles per second. Now this formula is modified as sine. All of you read out what it is written on the screen. This one, this letter, anyone? Yes. Anyone read out what it is written?
Current or sine?
It is W, it is visible. We call it as omega. Omega we are going to make.
Omega.
Okay? Omega formula is what here? Omega is equal to F into 2 into pi. Omega is equal to F into 2 into pi. Sir, what is this omega? Why I have to write the omega? Now listen carefully what I am explaining. If you are sending, see when you are getting disturbance, you have to mute yourself. Sir, why I have to write this signal, this equation? So from one cell phone to another cell phone, when we are talking, we are sending the signals through the air. Draw the diagram of this signal means this one only. And what is the equation of this signal transmitted? E is equal to Em sine omega. Omega means it is moving at different frequency, different energies. Okay. Therefore, we say it is omega is equal to 2 pi f. So whenever you are sending the energy into the air, that energy travels from one place to another place. Write the equation of that energy. What is the equation, all of you? Em sine omega t. So you have to remember the formula. V is equal to Vm sine omega t. Similarly, what about the current? Current formula, same condition, instantaneous current, Im sine omega t. Is it clear, all of you? So now when we do the problem, you will understand. Now all of you be ready with the solution. What is the question? Anyone read out the problem? You can also write simultaneously answer. Anyone read out? A 240, visible or not? Please tell me.
Voltage.
Yes.
Voltage AC supply is
Okay.
connected to an
80. All of you see here. 240 volts. That is, we are getting from our switchboard. AC current, alternating current, is connected to 80 ohm resistor. That means to one bulb. Calculate what they are asking. Calculate the current flow. So all of you, current. So we say, all of you listen here. V is equal to how much they have given? 240, which is equal to V RMS. We have taken the definition, all of you. I have given the explanation. Read that material also. RMS is the real voltage which we are getting to your house. So VRMS equal to how much? 240 they have given. But what they are asking you to calculate the current. So current formula, anyone tell me? I is equal to V divided by
V by R.
V by R. So why I have to write? Yes, I is equal to, please note, we should never get any disturbance. I is equal to V by R. Sir, why you are writing V by R? R, because resistor is given in the problem. If resistor is not given, different formula we use. So now what's going to happen? 240 divided by 80. How much, anyone tell me? 0, 0 get cancelled. 3 8 are 24. So answer is how many amperes? 3 amperes. Understood? So how much current is flowing? How much current is flowing? 3 amperes current is flowing. Current flow is this one. So this is the simple problem. Okay. Problems we have to be perfect, whatever we are doing. Now I am taking you to the next important problem, which will come in the examination, mid-examination also. Now you see. Okay. So slowly you understand. First time you are doing this type of problems, it will be somewhat new, but you have to understand. Now all the students, one simple question I am asking. Okay. Now what you have listened. I am sending the signals. When I dial a number in my smartphone generates certain signals which we cannot see with our eyes. What is the name of that signal? Anyone? Electromagnetic signal. First day I have shown you the animation. We send the signals into the space. Okay. So when we dial a number, our smartphone generates and sends the signals into the air, into the space. So what is, write the equation of that signal. So this is the equation. What is the equation, all of you? V is equal to Vm sine omega t. You have to remember this one. V is equal to Vm sine omega t. Just now I have shown you V is equal to Em sine theta. Okay, that is the, that you can write, or this one. So I request you to remember this one only. V is equal to Vm sine omega t. Sir, why you are writing omega here? Why you are writing t? Because the signal which is transferred from, which is sent by the cell phone, it changes with time. Therefore, please mute all of you. Okay. Sir, why you are writing? Okay, the signal is voltage. Okay, I agree with you. It is having maximum value. Vm we have written. Okay. And the signal is changing with respect to time. That's why we have to write T. And the signal is having different energies. Energy means frequency. Okay. For long distance, we should have dash frequency. High frequency or low frequency. First class I mentioned. Yesterday I mentioned also. High frequency means the signal can be transmitted for long distance. Yes or no? So in your house, from remote control to television, you are using which frequency? Low frequency or high frequency?
Low frequency.
So omega means it is the combination of number of frequencies. So omega is equal to 2 pi. We have studied. Circle means 2 pi. We have studied in mathematics, area of the circle. Yes or no? So that energy, it rotates in circular directions. Therefore, omega is equal to 2 pi f. Understood, all of you? So what is the equation of energy transmitted from one place to another place? Means you can write V is equal to Vm sine omega t, or I is equal to Im sine omega t. Is it clear, all of you? Now you see the question. This is the question. A sinusoidal, sine wave or sinusoidal, names will be different. A sinusoidal waveform means current or voltage. Sinusoidal waveforms are, show me the sinusoidal waveform means just know what you have drawn. And all our cell phones, they send which waveform, sinusoidal or sine waveform. Simply sine is defined as, okay. See, no student has to unmute, okay. Is defined as, what they have given in the problem? Vm. We have to see carefully. Vm means what? Anyone tell me maximum value? Vm is equal to 169.8 into sine, in the brackets, sine of, we say 377 into T volts. What is the voltage value they have given? Anyone tell me? 5 volts they have given, 10 volts? No, they have given Vm is equal to 169.8 into sine into 377 into T. You can ask, sir, what is this? We are not understanding. Our cell phones, when they send these signals into the space, they that energy, the signal voltage is written in terms of this expression. Now this is the first base of the diploma here. Understood, all of you? Voltage formula is not always IR. So voltage formula is what? Anyone tell me now? What is the AC voltage formula? All students remember and tell me. What is the AC voltage formula? Anyone? AC voltage formula is V is equal to Vm sine omega T.
Omega T.
Sir, I want to send the signals. Yes, NASA people, they send the signals into the space. The voltage value is this one. You have to remember this one. So question, they have given this value. What you have to do, we must write the formula. So this is the answer starting from here. We know that general expression for sinusoidal, general expression is this one. No need to write this statement also. Whenever you see this type of equation, write the standard formula. V is equal to Vm sin omega t. Now compare, all of you. So what is the formula? Vm. In the place of Vm, what it is written? Anyone tell me? 169.8.
169.8.
So Vm is equal, yes, only 169.8 is written. So Vm is equal to 169.8. Vm maximum value is how much here? 169.8. So in the place of omega, how much it is written? Anyone tell me? In the place
377.
377.
Yeah, omega formula is how much? So in the examination also, first we write Vm is equal to 169.8 and omega is equal to 377. But what they're asking, calculate RMS voltage, root of the mean of the square of the currents or voltages. RMS voltage is the real voltage. So what is the formula? In the first unit I mentioned, for you as your diploma, there is no proof why you are writing 0.707. Okay. So VRMS formula is what? 0.707 into maximum value or peak value. What is maximum value? Vm. Maximum value is nothing but Vm. So what is the formula for RMS voltage? All students remember 0.707 into maximum value. So what is the maximum value? How much you have taken from comparison? 169.8. Therefore, VRMS equal to 0.707 into 169.8. So 120 volts. So if somebody asks you what is the voltage of the signal which is generated, you can say 120 volts. Understood this problem? They will give this equation. You must write the standard equation. Compare in the place of Vm we are having 169, omega we are having 377. Compare and you will get this particular value. VRMS equal to 0.707 into maximum. Okay. Now let us move to the next part. So let us calculate the frequency. Next bit. Now we'll do the next one. This is very important, all of you. Frequency. When I speak, whenever we speak, we generate the frequency. Whenever you clap, you generate the frequency. So frequency is nothing but the number of cycles, positive cycles and negative cycles passing per second. If frequency is not present, you cannot communicate with one phone to another phone. How we are communicating means when we send the signals, they travel. When they travel, they got the frequency. Okay. But here we are calculating. So angular velocity is the speed at which the signal is transmitted. Omega, how much given in the problem? 377. Okay. Radians per second, units we'll see later on. So omega formula, anyone tell me? What is the formula for omega? Omega is 377. Omega is equal to, I just told you, 2 into pi into f. All of you must remember omega is equal to what is the formula? 2 pi
2
f,
pi f.
where pi value is 3.14. All of you. Pi value is 3.14.
1
Okay.
4.
So pi, how we got 3.14 is not related to us. Okay. So first we'll see that one in the later stages. Pi is equal to 3.14. 2 pi f equal to 377. So frequency is nothing but f. So what is the formula? F is equal to 377 by 2 pi. How much you are getting, all of you? You can calculate later on. 60 hertz. Units of frequency is hertz. 60. Understood this one, all of you? RMS and frequency. Okay, now we are going to the next problem. I hope you will explain this one. Now come to the next problem. Observe carefully. A sinusoidal alternating current or AC current or sine wave of what is the value? 6 amperes. 6 amperes current is flowing through a resistance of 40 ohms. That means 6 amperes current is flowing through the bulb. Bulb opposition is how much? 40 ohms. Calculate average voltage and peak voltage. All of you. Average voltage and peak voltage. So whenever they give the resistor in the problem, all of you remember, whenever they give the resistor, you can write V is equal to I into R. If they are not giving resistor, what we have tried? Anyone tell me? If they are not giving resistor value in the problem, what we can write? Another formula? Tell me now. V is equal to, which formula we have tried if resistor is not given? Vm sine omega t.
Vm sine omega t.
Omega t.
Remember that formula for your lifetime. Okay. So if resistor is given in the problem, we can say V is equal to I into R or RMS. Whatever the voltage they are asking, RMS voltage they are asking, average voltage they are asking, peak voltage. But without calculating RMS voltage, we cannot calculate average. Therefore, VRMS or V both are same only. I into R. Current how much they have given? 6. Okay. Current how much they have given? 6. 6 into ohms how much resistance? 40. 6 into 40 is 240 volts.
240
Okay.
volts.
Now they are asking average voltage. Okay. What is the formula for average? So in the first unit I have told you certain formulas you are supposed to study. Okay. So this formula. Yes, please mute all of you. Form factor equal to RMS voltage by average voltage. From this one, average voltage equal to RMS by form factor. Form factor value is always 1.11. Remember, this is a 2 marks. For you, there is no proof how you are getting 1.11. So first you have to remember, in the second year, you are going to do the proof, how we are getting the value. So what is a form factor? You can ask, sir, why you have to study form factor? Means when I say we are sending, when we dial a number, we are sending the signals from one place to another place. All of you are able to listen the signal with good clarity, no? All students. When you dial a number, when you talk with your friends, you are able to listen the signal with good clarity. So if the signal is listening with good clarity, the form factor value should be 1.11. The form factor value should be 1.11 and the peak value should be 1.414. Otherwise, we will not listen the signal with good clarity. So what is the formula for form factor? Form factor equal to RMS voltage by average voltage. From this one, average voltage equal to VRMS by form factor. Just substitution, you will get the average voltage. What is the next value? Is they have given peak voltage. Peak voltage or maximum voltage. What is the formula? All of you. Peak voltage equal to RMS voltage into 1.414. What is this 1.414 means? It is a peak factor. In the first unit, I have given the definition of peak factor. Peak factor equal to RMS voltage by peak voltage. Okay, so simply you remember peak voltage formula and this average voltage formula. You can substitute. Okay, so you can ask one question, sir, how 1.414 is created? Peak voltage is equal to RMS into peak factor. Peak factor value is how much? 1.414. We have to
0.11.
remember. So once again I'm telling, whenever we listen the signal with good clarity from one cell phone to another cell phone, two values should be constant. One is form factor 1.11 and peak factor 1.414. I will share at the end of the class this definition what I have given. Okay. So just substitution will get. Now I require you people to do this problem now. Do along with me the next problem. Now, ready all of you?
Ready, sir.
Okay, calculate amplitude. See, amplitude means peak value, energy, strength, intensity, magnitude, all are same. Calculate amplitude means all of you, in any question, if you see this type of equation, first write the expression. What is the expression, anyone? V equal to V m into sine, yes, omega
Omega T.
sine omega t.
T.
Inside the brackets or outside the brackets also you can write into t. Okay. Now, yes, please don't, you should never get this. Calculate amplitude they are asking. Amplitude means what here? Vm. So Vm is equal to how much amplitude? 220 volts.
220.
Is it clear? Now tell me, anyone, omega, what is how much omega? Omega is equal to how much?
314.
314. And omega formula is how much? 2 into
Pi.
2 into pi. So let me,
Pi F. 2 into pi.
2 into pi. Let me draw this particular pi. 2 into pi into f.
Pi.
Understood? 2 pi f. That's enough. Omega. So what they're asking, first amplitude. First bit is done. This amplitude is nothing but Vm is equal to 220 peak value. Second bit, what they're asking? RMS value. Yes or no? All of you. So now we'll write RMS. Remember, RMS value I should calculate. Resistor is not given, so we cannot write I into R. So what is the formula for RMS value? Just now we have taken RMS value. Formula is nothing but
1 point.
no, RMS value. VRMS equal to, all of you remember, always remember. So now I am writing VRMS. RMS voltage equal to 0.707 into Vm. Understood, all of you? 0.707 into Vm. VRMS equal to 0.707 into Vm. So now what is Vm? Anyone tell me? Now I am substituting. So now I am substituting here 0.707 into Vm is amplitude. How much they have given? 220. Yes or no? All of you. So you just see here RMS. I'll show you here once again. Here we have written. Is it clear, all of you? See now. Anyone read out? Are you able to see this formula? VRMS equal to formula is what?
Yes,
0.707 into peak value or maximum value, which can also be written as Vm.
Maximum value.
So always remember VRMS equal to 0.707 into Vm or IRMS. If they are asking current, IRMS equal to 0.707 into Im. Okay. Now just multiply with your calculator. Okay. So how much you are going to get, we'll see. Anyone, just later on you tell me. Multiply and tell me. I'll go with the second bit. Now how to calculate second bit? Second bit, what they're asking? Just multiply and tell me. If you're having calculator, 0.707 into 220. Later on you tell me. Okay. Frequency. All of you tell me how to calculate frequency. Formula. W is equal to 2 into pi into f. Yes or no, all of you? All students?
Yes, sir. Pi
W
into
2 into pi into f. So pi is how much I mentioned? 3.14. We take directly 3.14. That is the formula. Into 2 into 3.14 into f. Okay. But how much omega is given in the problem? Omega. So now we'll write. Omega, how much they have given in the problem? Tell me, anyone? 314. So 314 equal to 2 into 3.14 f. Okay, f. So what we get? F is equal to. So f is equal to 314. 314 divided by 6.28. No, all of you. 3.14 into 2, it is 6.28. Okay. Anyone do, if you are having calculated? 314 divided by 6.28.
RMS value వచ్చింది 155.54.
Very good, very good. ఎంత చెప్పండి RMS value?
155.4.
Very good. 155.54.
0.54.
Volts. Units are voltage kada idi. We have to write V here. Ippudu idi cheppandi. 314 divided by 6.28. Frequency. I will go with the next one. Time period. So time period formula T is equal to 1 divided
Sir,
by
50 sir answer.
okay, 50 hertz. Okay, so 50 Hz we can write. Okay, so frequency. అంటే ఇప్పుడు ఈ ప్రాబ్లం మీనింగ్ ఏంటి? we are sending signals from our cell phone. So when you send the signals from the cell phone has got the maximum amplitude, maximum voltage. Peak voltage is how much? 220. And that signal is doing certain real work. So that signal RMS voltage. RMS meaning ఏంటి అసలు? ఆ సిగ్నల్ మనకి ఒక సెల్ ఫోన్ నుంచి ఇంకో సెల్ ఫోన్ కి వెళ్తుంది అంటే ఆ RMS వోల్టేజ్ అనేది ఉండాలందు. సో ఎంత వోల్టేజ్ చూపిస్తుంది RMS? 155.54. First definition I have given. Anyone today only you read. Remember RMS voltage is a part of AC voltage. అందుకని ఇక్కడ వాల్యూ ఎంత వచ్చింది మనకి? 155.54 is a part of 220. Now all of you are understood? All students. Always RMS voltage will be less than peak voltage. Less than peak voltage. Okay, and our cell phone signal is traveling with certain frequency. Frequency how much for this problem? 50 hertz.
50 Hz.
ఇప్పుడు చూడండి సింపుల్ క్వశ్చన్. ఇప్పుడు మీ ఫ్రెండ్ మీ ఫోన్ నుంచి మీ ఫ్రెండ్ కి పంపించాలంటే 50 hertz ఓకే. కానీ మన ప్లానెట్ ఎర్త్ నుంచి ఇంకో ప్లానెట్ కి సిగ్నల్స్ పంపించాలంటే 50 hertz సరిపోతుందా? నో, ఇట్ షుడ్ బి వెరీ మచ్ గ్రేటర్ దాన్ 50 hertz. Understood? So that's why we are all calculating this one. So when a signal is transferred from one place to another place, it has got peak voltage or maximum voltage, RMS voltage and frequency. Ippudu time period. Well, next adugutundi enti? Time period. What is the formula for time period? Remember, always T is equal to 1 by F. It is a reciprocal of frequency. Do anyone? 1 by 50. 1 divided by 50. 0.05 check cheyandi. 1 divided by 50. Time period of sine wave.
0.002 sir.
All right, 0.002.
002.
Okay, time period kada time means units are seconds. Okay, all of you 1 by 50 0.02 or 0.002. 1 by 5 is
0.02 sir.
02, right? Okay,
Not double zero sir, only 0.02.
0.02.
Not double
0.02.
Yes sir.
02. Yes,
That's correct.
yes. So all of you, that finishes the problems. So problems, you remember 3 formulas: RMS voltage, and next one is nothing but this equation. Okay, now these formulas are finished. Yesterday also I have shown you in the material I have added. No need to study this one, only just see and watch. If you go to one electric shop, you must recognize what are this one. Okay, now so problems are done, the derivation is done. What is the resistance formula? Change in the value of resistance. Anyone tell me? When temperature changes, resistance changes. What is that formula of change in the resistance? RT is equal to R naught into 1 plus alpha into T. Just now we have taken today this derivation. Now anyone tell me what it is visible on the screen? RT is equal to yes, read out anyone this one. RT is equal to
R naught into 1 plus
alpha into
alpha
T.
T.
So enti meaning enti? Whenever temperature changes, resistance also changes. So the relation between initial resistance and new resistance, this derivation. Okay, so now all students, the next topic they will ask you, what is a fault? Fault means what? All of you, anyone tell me? In your house, let us say you are placing your hand in your switchboard, you will get shock. So that is called the fault. Okay, so VDR. So remember all of you, LDR full form, anyone tell me? LDR means light dependent resistor. Okay, see, please stop doing this. Those who are doing, they will fail in exam. VDR means voltage dependent resistor. What we have studied yesterday, varistor. Okay, right. So now one simple theory question is there. Now yesterday this trimmer Many people have not understood trimmer. Trimmer is nothing but potentiometer. Trimmers are of two types. Okay, one is trimmer, other one is preset resistor. Preset resistor. So trimmers are used in dash circuits, tuning circuits, remote control circuits. This is the symbol you have to remember, trimmer. So now for your understanding, I brought one more statement, which is single turn. See, single turn potentiometer is preset and multiple turn potentiometer is trimmer. Understanding all of you? Trimmer is having n number of turns of a copper wire and preset is having only single turn. So that is the only difference you can take. Now, let me take this one, this topic. Common faults in resistor. Okay, this question is theory question. All of you listen. Common faults in resistors. Common fault means what here? See, I will show you this circuit. Examination also you have to draw. All of you carefully you see this circuit. Tell me what is the fault in this circuit. All of you. Circuit is visible? No, no. All students.
Yeah, sir.
Yes. How many resistors? Three resistors. They are connected in series. Now tell me, see the circuit and tell me, anywhere disconnection, not connected is there or all are connected?
There is one disconnect.
Ah, yes.
Not connected is there, sir.
Yes, you must draw asterisk explaining the fault. Here there is no connection. When there is a no connection between two resistors, then a fault occurs. When fault occurs, it is called open resistor. Resistor is open. What type of fault is this one? Open resistor fault. So that's why we have written here. Common faults, names you have to write. What is the first common fault? Open resistor. Open resistor, where it is seen in resistors are connected in series. So just draw the circuit, write the name. That's all. Open resistor fault. And if you want, you can write this line. Okay, or else no need to take. Open resistor. Next fault. Next second circuit you see all of you. Resistor in parallel. Tell me, where is the fault? R1 is fault, R2 is fault, or R3 is fault? R1 is open.
R1 is fault.
Yes. Sometimes what will happen in the circuit, resistors, when large current flows, these resistors will break down. So we must check that one. So fault in the circuit means resistor. See, people say in our house we got the short circuit. Let us say in your house you are having the fridge. Inside the fridge, any component is open. When it is open, what's going to happen? The fault is created. That's why we use the stabilizers for television and the fridge. Okay. So this is the open resistor fault in which connection? Parallel or series? Parallel. Parallel connection. Okay. Now, parallel connection. Now what next you are seeing is very important. So anyone read out this heading?
Short circuit resistor.
Short circuit means maximum current. Remember, short circuit means maximum current. So how to do short circuit? In your house also, you don't do, but I'm telling you, you take one copper wire. Copper wire is having two ends. Okay, two ends. You keep those two ends in one hole of the switchboard and you check what will happen. Your entire house power supply will be off. Don't do that one. Okay, you will also get shocked. But in practice, I'm telling. So in our circuit, right, 31, any question is there? You can ask me. Roll number 31, raise the hand. Okay. Now you see, short circuited resistor. Short circuited resistor means what? You must draw, that's all. So this is the normal circuit where I'm having two resistors. Okay. That means let us assume R1 is bulb and R2 is fridge. Okay. Now short circuit, when it will happen? All students see. Let us say your fridge is entirely placed inside the water in a drum. Let us assume that your fridge is placed inside the drum and the drum is filled with the water. Then water is a conductor. Then what happens? The resistance of the fridge is 0 and fridge is nothing but just like short circuited. So show me short circuit means replace that resistor and draw one copper wire. This line we are going to write. Okay. So this line indicates that maximum current is flowing and it is under short circuit condition. Understood all of you? So short circuited resistor is also a fault. So short circuit means what? Maximum current is flowing and any element is replaced by the copper wire only. So this is the thing here. For your understanding, I mentioned. Imagine here we are having the bulb. Okay, R2 is acting as bulb, and that bulb is entirely damaged. When the bulb is damaged, not off, it is entirely damaged. Let us say under damage condition, large current is flowing and it is called the short circuit. If you touch this wire, now you will get the shock. So how to explain once again means, if you are taking one rod, iron rod, and if you are placing inside your switchboard, what will happen? Short circuit condition will be created. Okay. So that is what short circuited resistor. Only diagram you are going to write. Now you see. So now, okay, right. If you are having one load, in parallel you have to place the copper wire. Short circuited resistor is one type of this particular fault. Yes. Irregular contact or loose connection. Noise in resistance. This is important, all of you. Next class I will show you the animation. All students remember this definition. What is the noise? Yesterday I mentioned, till yesterday's class, it is a disturbance. All of you, electrons has to flow in which direction? Uniform direction or random direction? Tell me anyone. In order to
Uniform
create
direction.
all electrons
Uniform
should flow,
direction.
very good. All electrons should flow in uniform, in a straight manner, in a linear manner. But in practice, for small period of time, few electrons will flow in random direction, zigzag direction, forward, backward, and few electrons will combine, will touch each other. Therefore, random movement or random motion of electrons in a resistor results in noise. Understood, all of you? What is noise in electronics means, whenever the electrons are moving in random direction, they interact with each other. As a result, noise is created. So noise is nothing but one disturbance. So when noise is created, uniform movement of electrons will not be done. So current value decreases. So this is one of the fault. What is noise, anyone? Whenever electrons are moving in random direction instead of uniform direction, noise is created. That's all. Okay. Simple line you can write. So now this theory is done. So today I will release the material here with the modified version. Last definition we'll see in the second unit. All of you, anyone tell me what is the name of, what is the formula for efficiency? Efficiency of a student, how well the student is studying. Output by input. Efficiency means output by input. Okay. So output means what here for the fan? Fan is rotating. So how much wind energy the fan is giving, it is output. And what is the input for the fan? Electric. We are connecting to the switchboard. Okay. So thermal efficiency, one definition is important. As we have mentioned, heat energy. Thermal, all of you tell me what this thermistor, yesterday we have seen. Thermistor converts dash energy to dash energy. Tell me. Yesterday we have taken thermistor converts. Yesterday I have shown you that candle example also. Very good. Thermistor converts
heat energy, then
heat energy to electric energy.
heat energy, then resistor decreases and current flows increases.
Very good. That means thermistor converts heat energy to electric energy. So
Electric energy.
Thermal efficiency means how much heat energy it is taking and how much electric energy it is generating. Okay. So here, if you want, you can draw this one. No need to, it is not compulsory. Only you can write this formula. Efficiency is always represented by this letter neta. All of you remember neta, this symbol. It is similar to N, but it is neta. Okay. So efficiency is equal to output by input. So now how to explain this thermal efficiency? So all of you see this word, heat engine. See, you are having bike, car. Okay, heat engine turns, what it converts? Heat energy into work. Work means what? If I am starting the bike, what's going to happen? Heat energy is created, and then after creation of heat energy, the bike is going to start. So heat engine converts heat energy into the work, useful work. Okay, work means the object is moving from one place to another place. So we say, what is thermal efficiency? You see here, thermal efficiency fraction of heat that becomes useful work, or simple words, the ratio between the work and the heat energy, the ratio between the work and heat energy. So one more answer, the amount of work output for a given heat energy. So when you apply certain heat energy, this if heat energy is converted into useful work, example bike as well as the car and the bus. So they all take the petrol or diesel, and that engine converts the heat energy. Petrol and diesel generates the heat. Heat energy is converted into the useful work. So which is called the thermal efficiency. Only this formula you remember, all of you. We got 1000 variety of topics. We cannot remember all. So in shortcut you have to remember for 2 marks this one. Efficiency is equal to work by heat energy. So heat is represented by Q in our subject. Okay. No need to have this diagram. Okay. This diagram is saying that heat we are applying, certain amount of heat is wasted and useful work is done. 100% heat is not used. Okay. So heat source, fuel, petrol or diesel. When petrol or diesel are heated up, heat energy is created. So 100% of heat is not converted to work. Certain portion is wasted. So wasted heat energy is fuel. Okay. So efficiency, thermal efficiency equal to work by heat energy. Work by heat energy. So one second, all of you. So trimmer we have taken. Yesterday we have taken. So trimmers are used in dash circuits, tuning circuits. Okay, VDR is used in dash circuits. Tell me anyone. VDR, resistor, voltage dependent resistor. It is used in, yesterday we have taken, VDR is used in all electronic devices or electronic circuits, smartphone. Yes, very good, very good. One student answered. VDR is used in phone. VDR is used in television. What VDR will do, anyone tell me? Whenever high voltages are created, VDR protects the smartphone or protects the circuit from high voltages. Okay.
Control the current.
Control the current. That is, it is protecting the voltage. So VDR means remember the voltage. Here I have written here. And most important word is automatically. So remember this, as is this line you have tried. That's all. So varistor or VDR changes its resistance value automatically with the change in voltage. That is, whenever voltage value increases, varistor or VDR changes its resistance value and provides constant voltage or safe voltage to the electronic circuit. Okay, that is the only definition. So next class we'll do the revision, all of you. So this problem you see, all of you. So temperature, you can do that one, simple part, substitution only. So what we have done here, it is important. Let me share, and when we got the time, we'll do one thing. Okay. Any question is there, anyone? Please ask me now. 4 o'clock we have started. No.
Please, sir, can I ask one thought?
Yeah, you can ask. Please go ahead.
Electrical wires connected.
Voice disturbance వస్తుంది, క్లియర్ గా అడగండి. సైడ్ లోకి వచ్చి ఎలక్ట్రికల్ వైర్ ఉంది. ఓకే.
ఎలక్ట్రికల్ వైర్స్ పైన బర్డ్స్ అంటే స్టే చేసినప్పుడు వాటికి ఎందుకు ఎలక్ట్రికల్
చెప్తాను చూడండి. మీరు ఫస్ట్ డే చెప్పాను అనుకుంటా. ఇప్పుడు అదే వైర్ పట్టుకొని మనం కూడా ఊగా చేయం కాదు. మనకి ఒకటి గుర్తుపెట్టుకోండి, కరెంట్ ఫ్లోయింగ్ త్రూ ది ఎయిర్ ఈజ్ ఈక్వల్ టు 0. అంటే మీరు కూడా పోల్ దగ్గర ఉన్న 3 వైర్స్ ఉంటుంది. ఒక వైర్ పట్టుకొని మీ కాళ్ళు ఎక్కడ టచ్ కాకుండా ఎయిర్ లోనే ఉన్నారనుకోండి, అప్పుడు ఏమవుతుందంటే కరెంట్ ఫ్లోయింగ్, మన కరెంట్ ఎప్పుడు క్లోజ్డ్ రీజియన్ లోనే వెళ్తుంది, కరెంట్ ఓపెన్ లో వెళ్ళదు. ఇప్పుడు మీరు ఆ వైర్ ని పట్టుకున్నారనుకోండి చేతితోని, మీ కాళ్ళు గాల్లోనే ఉంటే ఏమవుతుంది, కరెంట్ అనేది మీ హ్యాండ్ కి టచ్ అయ్యి మీ బాడీలోంచి వచ్చి ఎక్కడ వెళ్తుంది, గాల్లోకి వెళ్తుంది. సో కరెంట్ ఫ్లోయింగ్ త్రూ ది ఎయిర్ ఈక్వల్ టు 0. బర్డ్స్ కూడా పైన నించినప్పుడు వైర్ పైన అది లెగ్స్ కి టచ్ అయ్యి లెగ్స్ నుంచి బాడీలోకి వెళ్తుంది. తర్వాత ఎక్కడ వెళ్తుంది కరెంట్, బర్డ్ ఎక్కడ ఉంటుంది, ఎయిర్ లో ఉంటుంది. ఓకేనా, అప్పుడు దాని షాక్ కొట్టదు. కరెంట్ ఫ్లోయింగ్ త్రూ ది ఎయిర్ ఈక్వల్ టు 0. ఓకే, దట్ ఈస్ ఓపెన్ సర్క్యూట్, దట్ యూ విల్ సీ లేటర్ ఆన్. అయితే మీరు అడిగిన జనరల్ గా చెప్తాను, బర్డ్ వైర్ పైన నించుంటే ఎందుకు కొట్టట్లేదు. సో కరెంటు బర్డ్ లోకి వెళ్తుంది, వెళ్ళాక కానీ బర్డ్ హెడ్ ఎక్కడ ఉంది, అది ఎయిర్ లో ఉంది. సో కరెంట్ ఫ్లోయింగ్ త్రూ ద ఎయిర్ ఈక్వల్ టు 0, అది ఓపెన్ గా ఉంది. ఇప్పుడు ఇదే ఎగ్జాంపుల్ చూడండి, బర్డ్స్ కి షాక్ కొడుతుంది ఎప్పుడు తెలుసా, ఇంకో బర్డ్ కూడా వచ్చింది అనుకోండి, 2 బర్డ్స్ వచ్చి 2 టచ్ అయ్యాయి అనుకోండి, సెకండ్స్ లో షాక్ వస్తుంది. అదే బర్డ్ పోల్ దగ్గరకు వచ్చేసింది అనుకోండి, బర్డ్ కాళ్ళు ఏమో మనకి వైర్ పైన ఉన్నాయి, మళ్ళీ ఇంకోటి ఏమంటే పోల్ కి టచ్ అయింది బర్డ్ హెడ్, అప్పుడు ఏమవుతుంది, క్లోజ్డ్ రీజన్ అయిపోయింది, అప్పుడు షాక్ కొడుతుంది మళ్ళీ. అర్థమైందా ఇప్పుడు అడిగిన వాళ్ళు?
ఓకే సార్, థ్యాంక్ యూ.
Okay. Current flowing through the air is equal to 0. I can also say all of you, I will tell you one more thing, you can do that one. Okay, మీ దగ్గర ట్యూబ్ లైట్ ఉంటే, ఓకే, ఇక్కడ మనకి విలేజెస్ లో, ఓకే, పోల్స్ ఉంటాయి కదా, మనకి ఇక్కడ మనకి అగ్రికల్చర్ ల్యాండ్స్ లో పోల్స్ ఉంటాయి, పోల్స్ మధ్యలో కరెంట్ వైర్లు ఉంటాయి. ఓకేనా, మీరు ఏం చేయండి అంటే ట్యూబ్ లైట్ తీసుకొని ట్యూబ్ లైట్ కి ఒక స్టిక్ కనెక్ట్ చేయండి. ఓకేనా, కనెక్షన్ చేసి కిందనే నించోండి, ట్యూబ్ లైట్ ని ఆ వైర్ దగ్గరికి తీసుకెళ్ళండి. అప్పుడు ఏమవుతుందంటే ట్యూబ్ లైట్ ఆన్ అవుతుంది వైర్ కనెక్షన్ లేకుండా. ఎందుకంటే అక్కడ అంత కరెంటు పోతున్నప్పుడు అక్కడ ఎనర్జీ ఉంటుంది, మ్యాగ్నెటిక్ ఎనర్జీ. నేను అది యానిమేషన్ చూపిస్తాను ఎట్లుంటుందో, దట్ ఐ విల్ డూ. ఇంకా జనరల్ గా ఇట్లాంటి డౌట్స్ ఇంకేమున్నాయి అడగండి. ఇప్పుడు మనం కూడా వైర్ పట్టుకొని ఉండొచ్చు, కానీ మన బాడీ ఎక్కడ టచ్ కాకూడదు, ఎయిర్ లోనే ఉండాలి. కొన్ని మూవీస్ లో మీరు చూసుంటారు, హీరోస్ ఏం చేస్తారంటే ఒక బిల్డింగ్ నుంచి ఇంకో బిల్డింగ్ కి వెళ్తారు, వైర్ పట్టుకొని ఇట్లా వెళ్తా ఉంటారు. అక్కడ మీరు చూస్తే ఏమవుతుంది, వాళ్ళు దగ్గరకు వచ్చేసేటప్పుడు ఆ వైర్ వదిలేస్తారు. సో వెన్ యు ఆర్ టచింగ్ ద వైర్, you should see that your body is under air, your body is not contact with any object. Okay, current flows in closed circuit, in open circuit 0, open area 0. ఇంకా ఎవరైనా జనరల్ మీకు కొత్త ఐడియాస్ ఉంటాయి కదా, డెఫినెట్లీ విల్ డెవలప్ ది రోబో ఇన్ అవర్ విత్ రెస్పెక్ట్ టు ది సబ్జెక్ట్. ఇంకా అడగండి ఏమైనా డౌట్. Okay, today I'll release the video also and the material. You see the material unit 2. Okay, unit 2 material will be released. All of you are requested to start the preparation for the subject. Unit 2, what is there in the material, you study everything. Okay, still any questions?
Sir, మీరు
క్వశ్చన్స్ అవును, ఇప్పుడు ఇవాళ మెటీరియల్ పెట్టేసి రేపు రివిజన్ చేస్తాను. రివిజన్ అయిపోయాక క్వశ్చన్స్ మనకి ఏవేవి క్వశ్చన్స్ వస్తాయి, ఎట్లా వస్తాయి క్వశ్చన్స్ అనేది అవి కూడా పెడతాను క్వశ్చన్స్. ఓకేనా, అవి చదువుకోవచ్చు. కానీ ఇవాళ మెటీరియల్ పెడతాను, ఆ మెటీరియల్ కూల్ గా చదవండి ఫస్ట్. అదేదో చూసేసి రాయొద్దు, టెన్షన్ లేకుండా చేయాలి ఏదున్నా కూల్ గా. ఓకే, రైట్. షల్ ఎండ్ ది క్లాస్ నౌ? ఓకే,
Thank you, sir.
థ్యాంక్ యూ,
Thank you, sir.
థ్యాంక్ యూ.
Thank you.